if you refer back to the slides that I've given you, the Newton-Raphson method is the formula is given as this. So we wanted to know the roots using the Newton-Raphson methods. So this method, we're going to use the information that's given here and input it into MATLAB. So how are we going to do that? First, we click on New and we click on Script. It doesn't matter, script function will be, it will give you a similar M file anyway. Alright, so this is a new file. So what I'm going to do is to function space in bracket B equals to Newton method in bracket f df x naught and f's. So what does this line tell us? So this line, the blue font here, says that this is actually an argument stating that this is a function file, and the value, the square bracket means that b is the variable that we wanted to find, equals Newton-Raphson method would be the file's name of this particular M file. In brackets, there are 4 variables that we are going to provide. The first one is f. F here would be the function that will be provided later on, but also we also can provide it inside the M file itself, but we will talk about it later. And df is actually the derivative, the first derivative of that particular function. X naught is the initial value, and f's here is the absolute error of that particular function, or its stopping criterion. So in this case, you have to bear in mind that relative error is absolutely absolutely different from the relative error. So you have to, I'm going to talk about it later, but you have to know that relative error is it's against the previous value of x, while the absolute error is when you compare that particular x against the true error of that particular problem. Right, so we are going to have this the first line here. Right, so the second line, we are going to introduce the value of b here. So b, if you refer back to the slide, is actually xi plus 1. So b is xi plus 1. The variable that we wanted to find is equals to xi. So xi here is x naught, the initial guess, minus, if you refer back again, fxi is the function. So the function with using its initial guess as x naught, divided by df, the first derivative of that particular function at x naught. So this is when we compare it with the Newton-Raphson method, we are using exactly the same equation. Right. After that, we are going to specify a line where we are going to introduce the absolute error as the stopping criterion. So we are going to say R. This is stating that it's equals to absolute error of the function with the value of b and we wanted to say that as long as the absolute error does not reach the value of the stopping criterion, the iteration will continue. So then apps. So we are going to state that as long as the absolute error does not reach the value of the stopping criterion, the iteration will continue. So x naught will equals to b, and again we are going to call the Newton-Raphson matrix. So this is the iteration. Okay, so we put and right. So I'm going to save this. So I'm going to save. If you are doing it on the on the desktop MATLAB, you will see that when you try to save the F file, it will be directly state the name. But here, since we are using online MATLAB, therefore we have to do it manually. Right, so I just click OK here. Okay, so this is the Newton-Raphson method. Okay. After you have saved it, you have to make sure that the M file actually exists on the current folder or the path folder that we are going to call back later. So in this case, if you see on the right hand side, you will see that that particular file is already there. This is quite important because sometimes the student will save it in another folder, and when they try to call back that file, they got error. So this is particularly important for you to know. Right, so after we have done that, we can call back that particular, if you refer back, I just click on that particular file again. In order for us to call back that particular file, we need to provide, before that, we need to provide 4 variables, f, df, x naught, and f's. So before that, I'm going to just make it, alright. Okay, so I'm going to, first thing that I need to do is to define the function. So if you refer back to the function, so the function is this. So just go to first, I need to make sure to ensure that MATLAB knows that this particular line is a function. So I put calling the handler. Oops. X space I'm going to call back, copy. So this is exponent negative x, x. So I've already specified that f is a function of exponential negative x minus x, and the next line I'm going to specify the first derivative of that particular function. So again, I'm going to specify that this is a function of x. So negative exponential x, refer back, -1, right? Okay, as you can see that whenever we define a function in the workspace, it will keep or store all the values. Okay, here, right? So the third value that we need, or variable that we need to provide, would be x0. So we are going to x0 is equals to, so we refer back to the question, 0. Okay, so as you can see that x0 is equals to 0, stored in the workspace. And the final one would be the stopping criterion. So the stopping criterion here is 2%, so it's equals to 0.2. Right. So we already input or provide all the variables that needed, and we are going to call back this particular function. So we just copy paste that one, Newton-Raphson method, and we enter it. Right. So the value of the solution would be 0.5663. So this is the answer for this particular problem using Newton-Raphson method. Right, so we have already done the problem or solved the problem using Newton-Raphson method. So for second method, it's a bit similar, where for second method, it's a bit similar to the Newton-Raphson method. So if you refer back to the tutorial 3, first we need to specify that this is a function file, M file, with, instead of using B, we are going to use B because we don't want MATLAB to get confused. So P here, second, just put second, which means that this file will be called as second or named as second, and F is the function that we are going to solve. A here is the variables of that particular, the initial guess, the first initial guess. C here is the second initial guess, and F's. So F's here is the absolute error, the stopping criterion. Right, so after that, we also need to introduce the value of x0, x1, fx0, and fx1. Since if we refer back to the equation, we will see that contrary with the Newton-Raphson method, for secant method, we do not use the first derivative, but we are going to substitute the value of the first gas and the second gas into this particular equation. So this particular equation, xi would be the second gas, xi minus 1 would be the first gas. So what we are going to do is we are going to introduce the value of x naught as a, the value of a, x1 as c, f naught here as f x naught, and f1 is f x1. Right, so after we have introduced the variables, we are going to write down the second formula. So the second formula states that xi minus 1, xi plus 1, which is p, is equals to x1 minus f1 times x naught minus x1 divided by f naught minus f1. And we are going to introduce the error here. Okay. Right, so after we have introduced the error, we are going to say that as long as the absolute error does not reach the stopping criterion, the iteration will continue. So while and if the iteration continue, we are going to use x naught equals to p and x1, which is the second gas, equals to a, and f1 equals to x naught. Oh, sorry, so it should be f. We are going to copy this secant equation and paste it here, stating that if the stopping criterion is not reached, therefore we're going to iterate it again and again until the stopping criterion is reached. Right, so we're going to put and. Okay, right, so we are going to, okay, So what we're going to do, we're going to save it as secant file. Okay, right, so I'm going to clear everything. Clear. As you can see that if I clear everything, all the variables that I have saved in the workspace has been deleted or have been deleted. So CLC, I'm going to clear everything. Right, so what we are going to do here is we are going to call back the particular secant file. However, before we can do that, similarly with Newton-Raphson method, we need to give value to the variables, the 4 variables. So first would be the function. So we're going to say that this is a function. This is a function of x, where the function of x is exponential negative x minus x and the value of a here is given as 0, c as 1 is from the question itself. So initial guesses of 0 and 1. So 0 is A, 1 is C. And also the absolute, the stopping criterion of 0.02%. Call back that particular M file and right. So the answer is 0.5722 for secant.